Hello friends. Today our session that is third we will learn why 3D printing is needed, where it is applied and also what limitations we must be aware of when using this advanced technology. Myself Dr. Debal Pramanik, Assistant Professor of Swami Vivekananda Institute of Science and Technology. First, need of rapid prototyping or additive manufacturing. Rapid prototyping or 3D printing are very much needed for physical model making due to the following reasons. First of one is manufacturing complexity is free. In traditional subtractive manufacturing, a complicated design object shape is more difficult to make. On a 3D printer, complex or simple objects require the same effort. Next one is variety is free. A single 3D printer can make many shapes in contrast to traditional manufacturing machines which are much less versatile and can only make things in a limited range of shapes. Next one is no assembly required. 3D printer produces interlock parts. In modern factories, machines produce identical components that are later assembled by robot or human worker. Complicated design objects include many parts which takes a longer time to assemble and more expensive cost to make. But in 3D printer, no assembly requires. Zero skill manufacturing. Traditional manufacturing machines still demand a skilled expert to adjust and calibrate them. However, a 3D printer gets most of its guidance from a design file. To make an object of equal complexity, a 3D printer requires less operator skill than does a traditional subtractive machine, hence less money and cost. Next, less waste by product. 3D printers create less waste by product than do traditional metal manufacturing techniques, therefore reducing losses and increasing the efficiency. So, these are the basic needs of rapid prototyping or additive manufacturing techniques. Then, applications of rapid prototyping. One of the purposes of rapid prototyping techniques is the elimination of risks during the product development cycle. First on up is concept models. Rapid prototyping techniques allow prototypes of many complex parts to be made more quickly and cheaply than ordinary manufacturing processes. Design teams can perform styling and ergonomic studies. Therefore, they are able to check the prototype at an early stage in the product development cycle, then apply any important modifications to the design before producing tools. And rapid prototyping part can be used as a communication tool and also provides engineering concept definition not only for the design team specification but also for other interested parties. Next, functional or semi-functional components. Some rapid prototyping processes are used to produce functional parts that can be used directly at the assembly stage and also many successfully performs at the final production part. On the other hand, some systems rapid prototyping can produce parts with the reduced physical properties, less materials uses and decreased mass. Next, master patterns. Rapid prototyping parts can be used as masters to create production tooling. For example, they can be used to produce masters for silicon rubber tooling, spray metal tooling, or masters for epoxy tooling to be used in injection molding. They can also be used as one of patterns for investment casting molds and as masters in sand casting foundries. So these are the basic application of rapid prototyping technique. Next one is limitations of additive manufacturing. Though there are many advantages of deploying additive manufacturing for the fabrication of components, There are still limitations that prevent the deployment of the techniques as a complete solution to all manufacturing problems. Some of the major limitations are mechanical properties. As the process involves the addition of layers one over the other, layering and multiple interfaces can cause defects like porosity, cracks, delaminations, etc. In the component, further higher energy sources used in additive manufacturing can lead to a large values of distortions and residual stresses which can hamper the mechanical properties under dynamic loading condition. Particularly in metal additive manufacturing, various rastering patterns generate different solidification patterns and local variation in properties. Thus, it generates anisotropy in the build material. Next one is requires post processing. The surface finish and dimensional accuracy of additive manufacturing components are generally lower than conventional manufacturing methods. Further, post-processing techniques like surface treatments, heat treatments, etc. are necessary for improvement the properties of the built component. And last one is limited component size or small build volume. In most cases, the component size are limited by the machine size and thus the technology is limited to building components that are about 1 cubic yard in size while metal parts may only be 1 cubic foot. While larger machines are available, they will come at a higher cost. Thank you.